Okay, let's see what we got here. Okay, we got our next focus activity. You got number 3 the other day. This will be number 4, and then next week you'll get your number 5, and we'll see how many are going to be in this set. But after this, we'll go ahead and wrap up the notes for the sequences. You got your homework assignment. This is not going to be due until Monday, so you have several days to go ahead and take a look at it. But whatever time we have left, I'm going to go ahead and let you guys start working on it. And there are some problems I'm going to omit, so we'll get started in just a second on that anyway. All right, so focus activity. Let's see here. It says, number 1, a sequence is defined by u sub n equals 3n minus 2. It wants us to go ahead and find, now what does it mean u sub 1? The first term, there you go. Remember that little subscript, that's n, that is the term number you want to find. So what they're telling me here is that n equals 1. Okay, so u sub 1, 3n minus 2, that's just 3 times 1 minus 2. It is 1. There we go. Really? Yeah, I like to hear it. Okay. U sub 5, so that would be the 5th term. Okay, so that's telling me that n equals 5. So u sub 5. So 3n would be 3 times 5 minus 1. And what are we looking at? 14. That should be the 5th term. Okay.
Wait.
15 minus 1. Minus 1. Oh, it's a minus 2. I'm sorry. I was just seeing if you are paying attention, and obviously you were. Always got to throw those strategies out there. Keep you on your toes. No more than I was. Okay. And we'll finish up with C, u sub 27. U sub 27. So 3 times 27 minus 2. Okay, so first off, we need 3 times 27. Okay, so that's 81.
Minus 2.
Would be 79. And there we go. There we go. Okay, so that's easy, right? Okay. If we have the explicit formula, we can immediately jump to any one we want. Now, if we had the recursive formula and I wanted the 27th term, we would have to find all the previous terms leading up to 26 and then be able to find the 27th. Okay, number 2. Consider the sequence. We have 2, 9, 16, 23, 30. Show that the sequence is arithmetic. Okay. Yeah, so all I got to do is just really show that if I subtract some consecutive terms, I'm going to keep getting 7 over and over again. So, for example, 30 minus 23 is 7. Then we know 23 minus 16, 7. 16 minus 9, 7. Even 9 minus 2. Okay, so that's enough to show that it's arithmetic. I'm just adding the same value over and over again. Now, if it is arithmetic, do we call that 7 D or R? That's D. There we go. If it's arithmetic, that's the common difference. It's the variable D. It's R if it's geometric. That's the common. What's another word for fraction? Ratio. There we go. Ratio. Okay, so it says find a formula for the general term. So the way they're stating this is another way of saying find me the explicit formula. So this one we've been dealing with is going to be very useful to us. The first term plus n minus 1 times d. Okay, and we've seen this several times, but if I want to come up with the formula, the explicit formula, what's the one variable I don't sub for? N. We leave n alone. So u sub n equals, well, the first term is 2 plus n minus 1. And we found the common difference, d to be 7. Okay. Now what do I do? Yeah, we go ahead and distribute, combine my like terms. So let's see here. So u sub n equals 2 plus, that would be 7n minus 7. So it looks like my formula is going to be 7n minus 5. There we go. The 2 minus 7. Okay. We're okay? Okay. All right, now it says, yeah, go ahead and find the 100th term. So that means u sub 100 equals 7n, 7 times 100 minus 5. Well, what would that end up being? 695. 700 minus 5. Okay, good, good, good. Now, these are some different questions we really haven't seen before for D and E. It asks, are these two terms a part of the sequence? Like, for example, 828. Yeah, if I were to continue creating this sequence, would I eventually hit one or both of these numbers? Okay, well, how can we figure that out? Okay, Antonio has a great idea. He said set the equation equal to that. So let's see here. If I have 828, and I'm going to set it equal to 7n minus 5. Okay, well, what would I do? Okay, so let's solve for n. Now remember, n represents a term number, so I'm going to add 5. There we go. So let's see, that would be 833 is equal to 7n. And Marcus is absolutely right. We will divide by 7, so let's see here. If I can get this. 833 divided by 7. Okay. All right. Now, how would we be able to tell if yes it is or no it isn't? That's exactly right. When we're talking about our term numbers, you have the first term, the second term, the third term, and so on. We don't have a portion of a term, like there's no such thing as the 1.5 term. They have to be whole number values. So what I'm looking for in this case, yeah, is no decimal. If it gives me a perfect whole number, then that means it would actually be the 119th term of the sequence if I were to continue. Okay, very good. So this one here, that is a yes. It should be a part of that sequence. Well, let's do the same thing for the other one, 2341. 2341 is now equal to 7n minus 5. I'm going to do the same thing. Let's see, add 5, add 5. So those are going to cancel. So this is 2,346 is equal to 7n. Divide by 7. So Brandon's saying no. So I'm guessing we're going to get a decimal. 2346 divided by 7. Okay. Control Enter. Because it's giving me a decimal, that means no. Okay. In fact, this number should be between the 335th and the 336th term. Okay. Because we got a decimal. I will not find that number if I continue the sequence. Okay, good. Any questions on that? Anybody having a hard time? No? Cool, cool, cool. All right, well, go ahead and put those to the side. You've now got numbers 3 and 4. We'll be turning those in probably in a couple weeks. We'll have at least a 5 and a 6 coming up. Okay. Let's see here. Let's go ahead and save those changes. And we've been talking about sequences. Okay. So we seem to be doing well. I believe we've only got one problem left to go, because this is where we stopped yesterday. Okay, we did this problem, so I believe this might be the only one left. Okay. So what I want to go ahead and do, there's 4 parts here. I want to identify the common ratio R. Looks like I want to find the 10th term, and then I want a recursive and an explicit rule for this sequence. Okay. Now remember, the recursive rule had a formula that looks like this. The nth term is equal to R times the previous term. Okay. So the n minus 1 would immediately give you the term before, whatever term you were looking for. Now the explicit rule, it's very similar. There's not going to be a whole lot of simplifying here, but a sub n would equal the first term times R to the n minus 1. Okay. I think we mentioned the other day that these are going to have a lot in common with exponential functions. Okay. So let's see here. How could I figure out the value of R, the common ratio? If it was an arithmetic sequence, then we just went ahead and subtracted the consecutive terms, right? What are we doing now, Zach? There we go. We're going to divide. So I'm just going to go ahead and take a couple of these, like this, take 3 and negative 6. What does that reduce to? Negative 1/2. There we go. If I take negative 6 over 12, that again reduces to a negative 1/2. Okay. Would anybody like me to go ahead and take one of the fractional values, do the same thing? Okay. You guys trust me? You don't trust me? Okay, so let's do it. All right. So let's take 3/4 over negative 3/2. Now, what happens when you divide by a fraction? A reciprocal. So this would be 3/4 times negative 2/3. So those threes are going to cancel. And what is negative 2 over 4? It would be negative what? 1/2. Okay. So the common ratio is negative 1/2. Okay. So negative 1/2. There we go. Now, why don't we go ahead and get the rules down before we go ahead and find the 10th term? Okay. So let's see here. For the recursive, we really just need to go ahead and fill in the one item that we just found. So I'm going to go ahead and say a sub n equals negative 1/2 times a to the n minus 1. Okay, that's all there is to it. For the geometric sequences, you're not going to have any simplifying like we did with the arithmetic. But there's 2 things I'm missing for the recursive. What do we always want to add to that? Oh, what has to be greater than 2? What variable? R or n? N. So we don't want to forget the restriction. N's got to be greater than or equal to 2. And there's one other item I always want to provide. A sub what? There you go. You always want to provide the first term. So in this case, the first term is 12. And it's really easy to forget those. But with the recursive formula, we want to give the first term and n greater than or equal to 2. And if you use that formula, that version, the restriction always is going to be greater than or equal to 2. Okay, well, let's get the explicit rule ready. A sub n equals, well, the first term was 12. What was r again? Negative 1/2 to the n minus 1. There we go. And again, there's no simplifying. Yes, sir. How do we get negative 1/2? That's where we were taking these consecutive terms, the ones right next to each other, and we were dividing them.
Oh, okay.
There you go. Because if we're multiplying to create the sequence, then we would divide to see how we got there. Do you want me to divide it a couple more? Sure. Okay. All right. So if I want to find the 10th term, well, that's telling me that n equals 10. All I got to do is plug that in here. So let's see. A sub 10 equals first term 12 times negative 1/2 to the 10 minus 1. But 10 minus 1, of course, is going to give me 9. And now we just got to figure out what that is. So let's see here. Let me document B out of that. We had 12 parentheses. I'm just going to go ahead and put in negative 0.5 because that's equivalent. To the power of, I'm going to use the caret button. Looks like the top of a house. 9. Okay. So who can help me out? What should I get when I push enter? Okay. So negative 3 over 128. Okay, what I ended up with, then negative 0.023. Now that should be equivalent. Let me go ahead and actually not do that. Let's go ahead and approximate to fraction. Negative 3, 128. Perfect. That is exactly right. Okay. Negative 3 over 128. There we go. Anybody having a hard time with sequences? Arithmetic, geometric, cursive, explicit. Okay. I believe that's the end of the lesson because we already did that yesterday. Okay, so here's what I'm going to have you do. I want you to go ahead and do numbers 1 through 29 odds. Okay, and then I want you to work 31, 32, and 34. So 33 and 35, you can go ahead and omit those. There is even one odd problem I'm going to have you omit, and I want to say it's number 11. But I'll give you a second to jot that down. So numbers 1 through 29 odds. And then I also want you to work 31, 32, and 34.
So no even number.
Except for 32. Oh, yes. I'm a math teacher. And I did this earlier. I'm really wanting to say, okay, so 8 was already gone because that was a even. 11, yes. So 11, go ahead and omit that as well. And I believe that takes care of everything. Okay. Absolutely. That's what we're going to do for the rest of our time. So if you guys are looking through this, yes, sir.
35.
No, don't worry about 35. 33 and 35, go ahead and omit those as well. Only 1 through 29 odds, 31, 32, 34. Okay. Is there a problem that you're looking at? You're not quite sure how we would do it that you like to do together? Oh, and I believe, I don't know if it's even or odd. Okay, there was a typo on 24. That should be a +3, but it doesn't matter anyway because it's even. Okay. Just in case you wanted to go ahead and work some more problems, and who would? Exactly. All right. So are there any problems you guys would like to look at together? Let's see. This first set, find the first 5 terms and the 20th term.
We just like one from each section. Like you know how like
One from each section?
Yeah, you know how like
Oh, to kind of give you an example?
of like each one you have to like.
I'd be okay with that. Now, I'll go ahead and start one, and then maybe we can get some folks up here to keep working some of the others. Well, I'll start with one, and then we'll see how many volunteers we got. So you want to do a problem from 1 through 6? No. Okay. Yeah, go and get the Okay. What number? Oh. The gentleman who just left. Oh, you're asking yourself. Ah. Gotcha.
Okay, Dad, I'll go to sign and get you get fired, huh? He messed up mine.
He messed up your what?
Yeah. Yeah, he messed it up. I said, what? Dude, who's working back there? I was. I'm going back over there. Bet.
Last night, not giving me what for.
Dude, I didn't work. What are you talking about?
Hey, you gotta grind all day,
No,
every
you
day.
don't. It's kind of off day.
Okay. Do we have a problem we want to work?
I'm gonna work on this problem with Marcus here, not serving you food.
Ooh, man.
I'm never gonna give you food.
The only problem I got
Okay,
right
which
now
one?
is that Marcus ain't giving me them water chicken strips.
So you want to do the last one, 34? I can do 34. Okay. Does everybody agree with that? Brandon says 34. Let's see here. What do we got? Okay. And you don't have to worry about 35. I mean, there was when I worked it with the other pre-cal class. So, okay. There you go. Let's see here. Find x so that x plus 2, and x plus 3 are consecutive terms of a geometric sequence. Okay, so the key here is the fact you're told it's a geometric sequence, right? Well, we actually just worked one of these a moment ago let's say I was wanting to figure out what the value of R was. How did we do that? Like when we had that 12, -6, 3, and so forth, how did we figure out that R was -1/2? We divided, right? We divided consecutive terms. Now, we don't know what these terms are because we're trying to figure out x, but the same idea still applies. So this second term here, x plus 2, if I go ahead and divide it by the first term, x, that should equal the common ratio, right? Whatever R is. So I also should be able to take the third term, x plus 3, and divide it by the previous term to get R as well. So where am I going with this problem? What do we notice about both fractions? True, but they both equal R. So if they both equal R, then they equal each other. So I can say x plus 2 over x equals x plus 3 over x plus 2. So I can create a proportion. It's based off the transitive property. Does this sound familiar, where if A equals B and B equals C, then A equals C? Does that sound familiar? Okay. All right, well, how do you solve a proportion? You cross multiply. There we go. So let's do this. What would I get if I multiplied x across x plus 3? So x squared plus 3x equals, now I got to multiply x plus 2 times x plus 2. I heard x squared plus 4x plus 4. Does anybody want me to show the FOIL, the distributive property on that? To show where the 4x came from? Okay. All right, so we're good? All right. Well, now you just go ahead and solve this equation. I would start moving like terms together. In fact, what's going to happen if I try to move 1x squared over to the other? Those are going to cancel. So it looks like I have 3x is equal to 4x plus 4. Okay, so you want to subtract the 4x? So minus 4x minus 4x. Those are going to cancel. So 3x minus 4x negative x equals 4. So is my answer 4? Now remember, we like the variable to be positive. So if I make that positive, then there we go. X would have to be -4. I'd say that was a good choice. That's it. This one just wanted you to find x, I believe. Yes. That's it. Okay. Would anybody else have had that idea to work the problem the same way? Oh, are you back to the beginning now? Okay. Okay. So you just want me to turn you guys loose? You feel comfortable now? Yeah. 3 or 5? Okay. So I'll go ahead and get you started here. Let me move this over to the side. So on 3, it says, okay, find the first 5 terms and the 20th term. So what I'm going to go ahead and do, like for a sub 1, what am I going to plug in for n? 1. So this would be -1 to the first over 1 plus 1 times 1 plus 2. Okay. Well, when you're dealing with this top portion right here, -1 to any power, what's going to happen if it's an odd power? It'll stay negative, so it'll be -1, but if you give it an even power, like square it, if you raise it to the 4th, then it'll give you a +1. So with this one being odd, that'll stay a -1 over. Looks like I'm going to have 2 times 3. So it looks like the first term has got to be a -1/6. Okay. And then I would just keep that pattern going with the second term. So what am I plugging in for n this time? So this would be -1 squared over 2 plus 1 times 2 plus 2. Now, because I'm squaring it, that's a positive 1 over 3 times 4. So I would say the second term is 1/12. There you go. And then you would just keep that going. You want to find the first 5, I believe, and then the 20th. Okay, so Brandon, does that help out? Okay. Did anybody want to come on up and continue that problem? This one right here. All you're doing is plugging it in and just simplifying, yeah? Sure. All right. Lexi's coming up. Lexi, would you also like to wear the headphones?
No, it's fine.
No? You don't want to talk to her? Okay.
I get nervous. So it'd be 80.
20 squared is 400, yes. Oh, yeah.
So what do I do?
Okay, now we already found the first and the second, so you want to find what?
Oh, the third.
There you go. We want to find the first 5 and then the 20th term.
So it's just dividing by half, right?
Well, if you think you feel comfortable with the pattern, so you're saying the next one should be a negative 1/24?
It should be.
Okay. Well, Nathan's already shaking his head no.
So there's no pattern.
So that's why I always like to find at least the first 3 just to make sure it's consistent. Just to be on the safe side.
Should be okay. A3.
Well, with an odd power, we know it's definitely going to stay negative.
Yeah.
Oh, cubed. There you go.
So under that would be 3 plus 1.
So that'd be 4
4.
times what?
5. No?
Yes.
5. So it'd be 1 over 20, right?
Negative 1/20.
But okay. Yeah.
Mm-hmm. That's it.
Okay. Well, there we go. I got it.
Okay. And then all you need to do is get the 4th and the 5th, and then the 20th. So at least we know the next one should be positive. Okay. Then the 5th one would have to be negative. What do you think about the sign of the 20th term? Would it be positive or negative? It would be positive. There you go. All right.
So there's like no pattern.
On this one, probably not. I mean, you'd be able to notice a pattern if you really analyze the explicit formula, but not one that we would notice right off.
I guess it's like those 6 things, and so like it's so at times it kind of like by itself exactly. So it's like 6 12, I think it's 20 30. It's like if you get the next one, so when you get the next one, you times that one. You know what I mean? It's like the next one you get like 36, the next one you get like 8.
Yeah, so the more terms you got, you could probably analyze it and figure out what's going on. Yeah, but with you only going 5, probably not on this one. Okay, good. Actually, you know what? I'll just leave that there. Okay. All right, so unless anybody wants to come up to the board, I'm going to go ahead and shut it down. Or do you want me to leave? I can go ahead and just shut down the video and you guys can still come up here. Okay, let me go ahead and do that.